Okay, this is going to be Algebra 2, Section 9.2, the first day. We're going to get into what logarithms are, and this picks up directly at the end of the last video where we solved exponential equations. Um, so basically, there was some I was mentioning at the very end that we couldn't figure out. Like, there's just no way to write them with the same base all the time. Okay, and actually most of the time you probably won't be able to do it that way. That was just kind of a little shortcut for certain situations, just to kind of see what was going on here. But the way to solve those is going to be using logarithms, and what they are basically is the inverse of an exponential. Okay, so they're kind of going to undo the exponent, which will help us solve for it. Okay, so let's take a look um, at what these are dealing with. So just a real quick recap. So yesterday, or in section 9.1, we solved ones like this equation here. We could take the 2 to the 2x. We knew that 8 can be written as 2 to the third, and then we were able to set the exponents equal to each other and go ahead and solve it that way, setting 2x equal to 3, and we could divide both sides and get our answer pretty quickly. Okay, now what if it was like the one on the bottom? 2 to the 2x equals 9. I can't write 9 as 2 to some power. Okay, and the reason I can't do that is probably because it's some crazy decimal that I'm just not thinking of, and most people don't do that stuff in their head. So there's going to be a way to do this, but it's not going to be the same method. It's going to be using this new idea of logs. Okay, so let's take a look at how those help us, what they do for us, and we'll do a few. Okay, this is the kind of the basic important thing here. When you want to change back and forth, okay, if you're given something written as an exponent like the ones we've seen, okay, the left side of this equation, okay, remember it's we use b for base, okay, and then we raise it to some power, and then that answer equals x. What you can do, you can rewrite that, okay, in what's called log form over here, where we're just rewriting the exact same thing, um, but it just looks differently, and we're going to be able to do some more things with it. So notice the base, okay, it's a little subscript down here. We say log base, whatever the base happens to be, some number. Same thing as the b over here. Okay, notice the x kind of switch spots. The x is now on the left side of the equation usually, and then the exponent is now what that log is equal to. Okay, so I want to make sure we're very comfortable with changing back and forth, because there'll be some problems where if you can just change from one form to the other, it will kind of lead you to where to go next. Okay, so you kind of get this transformation memorized over the next few times you look at this stuff. So let's just do an example. Let's rewrite one. Let's say they gave you some equation. They gave you 5 to the third equals 125. So if we want to write that in log form, okay, again, I'm noticing my base is 5, so that goes down as a little subscript. It's log base 5, okay, of 125 equals whatever the exponent is. Okay, so that would be that exact same thing written in log form. And just a couple things to point out. Notice you can kind of check these once you get things down, but basically you're saying 5 to the third power equals 125. Okay, it's the base to what power would equal the big number. Okay, and just a couple things. When you write these, try not to write it like this is not the same as what we have over there. Okay, and I notice some people write it that way. Um, the, the, the key difference here, this 5 is like a little subscript. It's lower. The base down here is lower. And the 125 is not the exponent. It's log, and then down here, and then 125 is written like equal on the equal line of where the log number is written. Okay, so it has a subscript of the base. Okay, so we don't want to write it that way. Okay, it's just a little thing that I've noticed. Okay, and we'll see what we're going to do with this in a second. Right now, we're merely just changing back and forth. So let's do the second one. Let's say they gave you log form, okay, and we want to be able to change it to exponential form. So we just want to rewrite it. So again, I always focus on ask myself, what's the base? Okay, and the base is always the little subscript there. So 3 is my base. I'm raising it to the second power, and that should equal 9. Okay, and it does. They gave us all the pieces. What'll happen sometimes is one of those pieces might be a variable. Okay, and we're going to solve for it. Okay, so again, just part B over here, focus on the base. Pick that out first. That's the base. Okay, here's the exponent. Remember, a log equals an exponent. Okay, and we'll talk about that a little bit later. And then the thing you're taking the log of, that is the answer. Okay, and that should be a true statement too. 10 to the negative second. Okay, that's why the 100 is in the denominator. Okay, the exponent was negative, so that's 1 over 10 to the second. Okay. All right. So, can we evaluate some logarithms? Okay, you may have noticed there's a button on your calculator that says log. We'll actually use that in a little bit later. Okay, but for now, let's just say we want to do log base 4. Okay, so that's how you would read this. Log base 4 of 256. And it equals some number. We're trying to figure out what that number is. So let's just say that it equals y or something. I don't know what it equals. Okay, so what I would do to figure out what it equals is probably change it to exponent form. We're more comfortable with that. We've seen that more often. So take your base to some power equals 256. Okay, that's what a log is. It's asking you what power do you have to raise the base to equal the number. Okay, that's all this is. That's all a logarithm is. What power do we raise the base to equal the number? Okay, what power would 4 need to get raised to equal 256? Okay, 4 to what power equals 256? And the answer to that one is 4. 4 to the 4th power equals 256. Okay, so that's the value of that logarithm. So we could say log base 4 of 256 equals, the answer is 4. Okay. All right, part B. What power would we raise 2 up to equal 1/8? Okay, or if you want to throw an equals y on the end here. 2, change into exponent form, to some power equals 1/8. Okay, what is the exponent? That's what we're trying to figure out. So in this case, I think we did one like this before. It's a negative exponent, and the answer here should be -3. Okay, right? Because the 8's in the denominator. 2 to the third is 8, so 2 to the negative third is 1/8. Okay, let's solve some log equations then. Okay, so they're giving you a log equation. One of the things is a variable. Okay, so we really need to know how to change to the other form here. Okay, so again, log base 9 of x equals 3/2. Get your base, pull your base out. The thing that the log equals becomes the exponent. Okay, and it equals x, and that's what we're trying to find here. Okay, so this should just be a little calculator problem. Okay, we're going to use our caret key. We're going to use parentheses to evaluate this. Okay, so this becomes, again on the calculator, 9 raised to the power of 3/2, and I got 27 for an answer. Okay, so x would equal 27. Okay, for part B over here, let's do the same thing. Let's change it to exponent form and see what we can do. Base is b, exponent is 2, the number that it equals is 9. So we're trying to find out what number to the second power equals 9. Okay, we go ahead and take square roots, so we probably know this one. The answer is going to be b equals 3. Okay, so that's what the base would have to be. We use b for that one. Okay, so that was a little intro. Again, there's quite a bit more to this. We're going to spread it out over a couple days. So the assignment for this portion will be page 515, numbers 23 through 49 odd. And pay close attention to switching back and forth. Make sure you're clear on what goes where. And I really think if you start with the base first and kind of get that one out of the way, it really helps to keep things organized. So that is 9.2, day 1.